So this is a picture taken in the interior of Igreja do Rosário in downtown Rio de Janeiro, Brazil. And I was passing in front of it today and I decided to go in and I noticed these skylights. Okay, so the interior of the church is remarkable because it comprises a few cylindrical sections, not all of the same radius. It gets a little radius is a bit smaller here and a little larger here. And there's a few skylights which are circular holes drawn through the top at various locations. So here you're seeing one of them, and there's another one closer to where this picture was taken, right above it, and it illuminates the church with natural lights. It's just beautiful, right? So you're basically subtracting a vertical cylinder from this, so to speak, horizontal cylindrical roof. Now I was more or less in the location where this picture was taken. This picture is not mine, and I noticed that one of the skylights had that shape from my point of view, right? So this looks like a very interesting thing. It looks like it's a non-convex shape with four critical points of curvature, and I decided in this Mathematica notebook to try to reproduce this phenomenon. Okay, so let's scroll down a bit. And here's a shape that I have concocted to approximate what I see at the roof of that church, right? So I have a cylindrical roof like that, from which, and it's a bit transparent, from which I have removed, let's look at this from the top, a circular slice. Okay, so I've drilled into this surface a cylindrical hole. Now, what's fascinating about it is as you view this hole from different viewpoints, the nature of its geometry, as it's projected right on the viewer's eye, changes in beautiful ways. For example, if I'm looking at it from below, as that church picture, right? Just go back to this church picture here. We're looking at it at a slant and from below. So if I look at this at a slant and from below, okay, I get this asymmetric shape. Now, if I'm looking at it right from the axis of the roof cylinder, I get a symmetric shape, but depending on the angle that I'm looking at it, okay, if I'm looking at it straight up, as I did today, you see the circular hole, but as you move away from the axis of the circular hole, the projection distorts into this asymmetric shape, and it would be great for us to know what the degree of this shape is. And then at some point, if you're far enough away from that vertical axis, okay, you pass through this critical point where this bottom part of the figure is no longer convex, but its curvature changes sign, so to speak, right? And as you move away and away and away, you get even a completely non-convex shape. Okay, so if you're just talking about rotations of the surface, about, say, in this case here, the cross axis of the main cylinder, what is the critical point of rotation that will turn this projection from a convex shape into a non-convex shape? Another interesting thing is, and the same phenomenon happens if you're looking at it from the top, right? You can see here that it's non-convex, and as I rotate the same more, at some point it becomes, right about here, it becomes convex. Now, if I'm looking at this from a slant, then I get this non-convexity. Now, an interesting thing as well is there are some viewpoints where you might actually be able to create a cusp on the curve. And if you keep moving that way, now the curve, if you can view it through the transparency, is this self-intersecting thing, right? So this is a pretty rich set of projections of a simple circular hole in a cylindrical roof. Over here, I'm just to illustrate this just a bit more, I'm now using orthographic projection as if I were viewing this thing from a pretty large distance. And what I can do here is I can slowly rotate the shape so we can see the full extent of the phenomenon. Let's go ahead and reduce the image here to 800 so it fits. And now we can fully rotate it like so. And let's rotate it a bit slower so we can appreciate what's going on. Now, it is interesting, right, that what we were doing, what I was doing in the church, and when that what where that picture is taken from, if I go back to that picture, the so if you think of that circular sector there as being our cylinder, right? This picture is taken not only far away from that vertical projection, but also much below the, say, xy plane or the z equals 0 plane of this cylinder, which would be around here, right? So this is where the cylinder, the top half of the cylinder intersects. Uh, let's say it's z equals 0 axis, and this picture is taken not only far away, okay, several radii away, but also at a depth that is below this mid curve here. So I'm getting further distortion. So one would have to investigate what happens also when the cylinder is viewed, if you can translate that cylinder, right? There might be a way to translate. Yeah, I can do that, I believe, and then I can look at it like so. Yeah, I think I'm looking at it from below now. So it'd be something like that, and I would have to send this guy backwards, okay? But, just to illustrate the whole effect and the phenomenon that we're talking about here, it looks like we have space here of projections that distort a circle into a set of curves of some degree, which we would have to ascertain. Okay, and then there's some questions of critical rotations, for example, right here, for which the curve which is rotated, one of its critical points of curvature, and there are always four, has zero curvature, right? So it's particular one of those guys. And then the question that I asked before, which is, are there slanted views that create cusps on this curve? What are those? What is a set of slanted views? What's the locus of such slanted views? Create cusps, etc., etc., etc. Okay, so very rich geometry here. Wishing everybody a happy 2025, and I hope to see you again soon. See you soon. Bye.